Hello everyone. Today we're going to be learning about domain and range. So domain and range are a representation of the range of possible inputs and outputs of a function, where the domain is the range of valid inputs into a function, which is also known as the range of x values in an xy plot. So if we look at our xy plot here of f of x equals x squared, a simple parabola, the range of x values goes like so, and seen as a parabola goes up and to the right to infinity, our range of x value is going to go to positive infinity to the right, and then the same principle holds to the left. It goes up and to the left to infinity. So our range of x values goes from negative infinity to positive infinity. Now, the range is a set of all function outputs over the entire domain, which is also known as the range of y values in an xy plot, or the range of f of x values given input x. So again, same plot, f of x equals x squared. We start at 0 here, and we go up, 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 up to infinity, giving us a range of 0 to infinity. Now you'll notice how I included the hard brackets when we're representing domain and range. Hard brackets stand for inclusive, and parentheses stand for non-inclusive. And the reason why I did parentheses at infinity is you can never actually beat infinity, right? You're just going and going and going. Whereas the domain, it starts at 0. So if you plug 0 in for x, we'll get a coordinate of 0, 0, meaning that the function actually has the y value of 0 in it. Okay? So now let's look at a couple examples. The first one being, let's say you go to McDonald's. You can buy food with any form of money, dollars, quarters, etc. Think of your money as your input. Your function is going to be McDonald's, and your output is going to be the food that you ordered and they give it to you, right? So you can think of the domain as the various kinds of money that they accept. Say a certain McDonald's you go to only accepts cash. Well, the domain is essentially the limit on the inputs. So if you can only input cash, this is what your domain would look like, where you have cash and then you have debit and credit cards out here, but those aren't included. Whereas if you go to McDonald's that only takes debit or credit, this would be your domain or your constraint on your input. And if you go to a McDonald's that accepts all of them, your domain would be totally inclusive. Now, again, your range is essentially your output, right? So based on whatever range of input you have, so again, say you can only pay in cash at McDonald's, the McDonald's will only output according to cash. If you try and pay with credit, your output, you won't get an output because they don't accept it, right? Okay? And another example, let's look at a graph here. So we've got f of x equals x cubed. You'll notice this part of the graph goes down and to the left to infinity, right? And this part goes up and to the right to infinity. So our domain is going to be from negative infinity to infinity because it's going to the left to infinity and to the right to infinity. And then our range is going to be negative infinity to infinity because it goes down infinitely and up infinitely. Okay? Let's look at a couple more examples here. We're being asked to solve for the domain and the range. And one thing I need to touch on is if we have a plot like this with a filled-in circle here at 0.11, this is essentially saying that this includes the 0.11. Whereas if we had a plot like this with a hollow circle at 1, that's not including the 0.11. The difference between that would be we'd use hard brackets here, and we'd use curly brackets here. So let's look at the domain first. Again, the range of x values. We see this part of the plot goes to the left infinitely. So our domain's going to start out from negative infinity. We come up here to 0.01. We notice that this is inclusive. And then it hops up to this plot and goes over and to the right infinitely. So our domain is from negative infinity to infinity. Now the range, again, looking at this same segment here, we notice that this plot goes down infinitely. So our range goes from negative infinity. We go up to 1, and it's inclusive, so we use a hard bracket. Then U is a way to denote the separation. And then we hop from 1 to 2, right? And 2 is not inclusive because it's a hollow circle, so we go from 2. And then we've got this asymptote, which we'll learn about in a future video, but it's essentially just a line that the graph approaches. So this graph approaches a y value of 3, but never gets there. So we have 2 to 3, non-inclusive for both, and this is going to be our domain and range for this plot. All right, one more example here. Let's start off with the domain. So again, starting from the left, we see that this plot goes up and to the left infinitely. So our domain goes from negative infinity. We go down here. We notice that this is hollow, so it's not inclusive, but this segment is inclusive, so we don't need to represent a jump there. We go up here to plot 0, 2. We notice that this is inclusive. Hop down here. We go down and to the right infinitely, so we get a domain of negative infinity to infinity. Now the range here is going to be a little more complicated. So starting at the bottom right, we see that we're going down infinitely. The range goes from negative infinity. Then we come up here to -1, a y value of -1, and we see a jump right here, right? So we think, okay, we want to have, -1 to 2 or whatever, not included. Well, this line segment includes that gap. So seeing as both ends of the line segment are inclusive, meaning that this y value is included in the range, we don't need to represent any gaps, and the range of this will be negative infinity to infinity because we jump from here up to here, and all of the values in between are plotted, and then we jump from down here up to here, and again, all those values are accounted for.